So today I'm going to be talking about Gibbs free energy. So right here in the picture you can say Gibbs free energy is defined as the spontaneity of a process. It's represented by this capital G right here. And basically it's just a measure of, will this reaction happen on its own? Is it going to happen on its own, spontaneous, or is something going to have to kick this off and it's non-spontaneous? So the equation for it is right here. Delta G equals delta H minus T times delta S. So delta H stands for change in enthalpy, delta S change in entropy, and the T stands for temperature. So once you're doing this equation and you come up with your answer, if your answer is a negative delta G, then that means that your value is spontaneous. Same thing, if you end up with a positive one, then your answer is non-spontaneous. So down here, if the value for delta H is negative, this means that it is exothermic and is energetically favorable. Now, if the value for delta S is positive, this means it has increased in entropy and is entropically favorable. So these two situations will lead to a spontaneous value. So what this just described is a negative delta H minus a positive delta S will result in a negative delta G, which is going to be spontaneous. So over here, positive minus negative equals positive. So that's going to be an energetically unfavorable delta H and an entropically unfavorable delta S, and that is going to equal a non-spontaneous delta G. So over in this other corner, we have positive minus positive equals positive and negative. So that is from a positive delta H, which is energetically unfavorable, and a positive delta S, which is entropically favorable. So that is going to be a spontaneous value when the value for the temperature, the T, is high. So since we said that delta S is going to be positive, so since that's positive and the temperature value is right next to that, it's going to raise the value of the temperature. So it'll be spontaneous when the temperature is high. So over in the bottom is kind of the opposite of what we just said the other one was. So a negative minus a negative equals a positive or negative. So that'll be an energetically favorable delta H, and an entropically unfavorable delta S will equal a spontaneous T value when it's lower. So same thing like the other one, we said that the T was going to be higher since I was at positive next to the delta S. So for this one, there's going to be a negative next to the delta S, which is then going to make that temperature value lower. So it'll be spontaneous when that temperature value is lower. So this example over here for this, I don't feel like reading out that chemical formula, you can see it. But the values that they gave us for that, for the delta H, it was negative 495.2 kilojoules. And then delta S was negative 136 J/K, and then T was 298 K. So delta G, that's just the equation, sorry. But our first step was to change that delta S value. Since they just did like just joules and not kilojoules, we had to change it from negative 136 to negative 0.136 kilojoules. So then we multiplied the delta S and the T value, and that gave us down here, we just moved that delta H value down. So it's negative 495.2 kilojoules plus 40.5 kilojoules, and that is going to make our answer negative 454.7 kilojoules. Sorry, I can't see it right there. And since that is a negative value, that means that our energy is going to be spontaneous. So this reaction will happen spontaneously. Nothing really has to kick it off. It can just happen.